Dear students, yesterday we discussed about the Cauchy sequence and its properties. So what is a Cauchy sequence? Secant xn is said to be Cauchy when modulus of xn minus xm strictly less than epsilon for all n and m greater than or equals a particular stage k following n. Agree? And a convergent sequence is Cauchy. Also, a Cauchy sequence is bounded. Now let us consider a problem. Let x equals xn be a sequence defined by x1 equals 1, x2 equals 2 and xn equals half of xn minus 1 plus xn minus 2. xn minus 1 plus xn minus 2 for n greater than 2. When for n equals 1 and n equals 2 it is defined, and for n greater than 2 it is xn is half of xn minus 1 plus xn minus 2. Prove that secant xn, our requirement is secant xn converges to 5 by 3. 5 by 3. So how? The solution is first we prove that secant xn is a bounded sequence. How to prove? First we prove xn is a bounded. Next we prove secant xn is Cauchy. Then after that every bounded Cauchy sequence is convergent. Then finally we prove that the given sequence converges to particular limit 5 by 3. Agree. So first we prove that the secant xn is bounded. For that, first we prove secant xn 1 less than or equals xn less than or equals 2. 1 less than or equals xn less than or equals 2 for all n fallen n. This is our first task. So when n equals 1, x1 equals 1, and when n equals 2, x2 equals 2, so the result called for n equals 1 and n equals 2. So assume the result true for all natural numbers up to k. Now by induction hypothesis, the result is true for when n equals 1 and n equals 2, result holds. Now suppose that the result holds for n equals q of the natural numbers up to k. That means 1 less than or equals xk less than or equals 2. Okay. Since it is true for every natural number up to k, immediately we have 1 less than or equals xk minus 1 also less than or equals 2. Agree? So on vertical addition, what do you get? 2 less than or equals xk minus 1 less than or equals 4 on vertical addition. Okay. That means 1 less than or equals half of xk plus xk minus 1 less than or equals 2. Agree? Okay, from here. If you divide it out by 2, 1 less than or equals half of xk plus xk minus 1. What about xk plus xk minus 1? xn minus 1 plus xn minus 2 of half is xn. So half of this one is xk plus 1. So that means 1 less than or equals xk plus 1 less than or equals 2. That means the result is true for n equals k plus 1. The result is true for n equals k plus 1. So by induction hypothesis, we have 1 less than or equals xn less than or equals 2. So the first task is over. Agree. First we prove 1 less than or equals xn less than or equals 2 for all n following n. So by induction hypothesis, we have 1 less than or equals xn less than or equals 2. So our first task is over. Agree. That means 1 less than or equals xn less than or equals 2 means here secant xn is a bounded sequence. Secant xn is bounded. Okay. Now we have to prove modulus of xn minus 1. Now we show that mod xn minus xn plus 1 less than or equals 1 by 2 power n minus 1. for all n falling in. Now the second task is we have to show that modulus of xn minus xn plus 1 equals 1 by 2 power n minus 1 for all n falling in. So again, when n equals 1, what happens? It is modulus of x1 minus x2. What is x1? That is 1, x2 is 2. So it is modulus of 1 minus 2 means 1. 1 means 1 by 2 power 0. That means the result is 2 for n equals 1. Agreed? Okay. Now we assume the result is 2 for every natural number up to k. That is modulus of xk minus xk plus 1 equals 1 by 2 power k minus 1. That is true for every k. Now consider modulus of xk plus 1 minus xk plus 2. Replace k by k plus 1. So it means we try to prove the result is true for n equals k plus 1. What is modulus of xk plus 1 minus xk plus 2? Equals modulus of xk plus 1 minus, what is xk plus 2? Replace n by k plus 2. What do you get? It is half of n equals k plus 2, k plus 2 minus 1. That is k plus 1. So it is x k plus 1 plus xk. Agreed? Okay. So that means this left side equals modulus of xk plus 1 minus half xk plus 1 is half of xk plus 1. Agreed? Okay. Minus what remains half of xk. That equals half of modulus of xk plus 1 minus xk. Agreed? So that equals 1 by 2 into half of, what is xk plus 1 minus xk? Xk, here it is, modulus of xk minus xk plus 1 is half 1 by 2 power k minus 1. So it is 1 by 2 into 1 by 2 power k minus 1 equals 1 by 2 power k. So the result is 1 by 2 power k means it is equals 1 by 2 power k plus 1 minus 1. That means the result is true for n equals k plus 1. So by induction we have xn modulus of xn minus xn plus 1 equals 1 by 2 power n minus 1 for all n falling in. So second task is also over. So first we prove secant xn is bounded. Secondly we prove modulus of xn minus xn plus 1 is 1 by 2 power n minus 1 for all n falling in. Now let m greater than n. For m greater than n, consider modulus of xn minus xn. Modulus of xn minus xn. What is modulus of xn minus xn? Modulus of xn minus xn equals modulus of xn minus xn plus 1. Agreed? Modulus of xn minus xn plus 1. So plus xn plus 1 minus xn plus 2 plus xn plus 2 etc. plus what about the last two terms? Xn minus 1. Agreed? Xn minus 1 minus xn. Enough? Okay. Xn minus xn plus 1 plus xn plus xn plus 1 minus xn plus 2 plus etc. plus xn minus 1 minus xn. So that means this left side less than or equals, by triangle inequality, it is modulus of xn minus xn plus 1 plus modulus of xn plus 1 minus xn plus 2 plus etc. plus modulus of xn minus 1 minus xn. Agreed? So that means according to this argument we have modulus of xn minus xn plus 1 is 1 by 2 power n minus 1. So this means left side less than or equals, what about this one? Modulus of xn minus xn plus 1 equals 1 by 2 power n plus n minus 1, 1 by 2 power n minus 1 plus the next term is 1 by xn plus 1 minus xn plus 2. So it is 1 by 2 power n. The next is 1 by 2 power n plus 1 plus etc. plus what about the last? Modulus of xm minus xm minus 1 is 1 by 2 power m minus 2. Agreed? 1 by 2 power m minus 2. According to this argument, xm minus 1 minus xm, or xm minus 1, 1 by 2 power n minus 1. Means here m minus 2, here it is m minus 2. That means take 1 by 2 power n minus 1 commonly outside. What do you get? So 1 by 2 power n minus 1 into, it is 1 plus 1 by 2 plus 1 by 2 square plus etc. plus 1 by 2 power n minus 2, take 2 power n minus 1 outside. What do you get? 1 by 2 power m minus 2 minus of n minus 1. Agree? That is 1 by 2 power m minus n minus 1. Enough? Okay. So it is less than or equals 1 by 2 power n minus 1 into 1 plus 1 by 2 plus 1 by 2 square plus etc. Enough? What about the term inside this bracket? That's a geometric progression, geometric series with the first term is a is 1, common ratio r is 1 by 2. So it's an infinite series, sum of an infinite series with a first term a, common ratio r is a by 1 minus r. So it is 1 by 1 minus 1 by 2 equals 1 by 1 minus 2 equals 2. So it is equals 2 by 2 power n minus 1. Enough? 2 by 2 power n minus 1. What is 2 by 2 power n minus 1? 2 by 2 power n minus 1 is, that can be rearranged as 4 by 2 power n. Okay, 4 by 2 power. 2 by 2 power n minus 1 is 4 by 2 power. Agreed? Okay. So for m greater than n, modulus of xn minus xm less than or equals 4 by 2 power. That's the third result. Agreed? Okay. So for m greater than or equals n, m greater than n, we have modulus of xn minus xm less than or equals 4 by 2 power n for all n fallen n. So there are three results. Secant xn is bounded. By using the second task, we prove modulus of xn minus xm less than or equals 4 by 2 power n. Enough. Now what about limit 1 by 2 power n? We have limit 1 by 2 power n equals 0. Sure? Yes. Limit 1 by 2 power n equals 0. Limit 1 by 2 power n equals 0 means limit, so what about the limit x power 2 power n? Limit x power 2 power n is also 0. Limit x power 2 power n is 0 means for all, by the definition of this limit, for all k fallen n is, or for all epsilon is positive, for all epsilon positive, there exists k fallen n such that modulus of x by 2 power n minus 0 strictly less than some epsilon. Here for convenience we take epsilon by 4 for all n greater than or equals k. Agreed? That means modulus of x by 2 power n strictly less than epsilon by 4 for all n greater than or equals k. Enough? Okay. X by 2 power n less than epsilon by 4 means, so therefore 1 by 2 power n, put epsilon, so x is 1, so 1 by 2 power n strictly less than epsilon by 4 for all n greater than or equals k. Enough? For all n greater than or equals k. Now, what about modulus of xn minus xm? Now consider mod xn minus xm, but we have mod xn minus xm less than or equals 4 by 2 power n. So it is less than or equals 4 into, what about 1 by 2 power n? It is less than epsilon by 4. So it is modulus of xn minus xm strictly less than 4 into epsilon by 4. That is from here. Less than equals 4 by 2 power n, but 1 by 2 power n strictly less than epsilon by 4. So you can replace equals epsilon. Means modulus of xn minus xm strictly less than epsilon for all n greater than or equals k. That means secant xn is a Cauchy sequence. Secant xn is Cauchy. So secant xn is Cauchy. It is bounded. Then therefore secant xn should be converges. Secant xn is a Cauchy sequence. Therefore xn converges. Secant xn is converges. Agreed. Now now to prove limit xn equals 5 by 3. Okay, that is our next, the last task. Limit xn equals 5 by 3. So for let we already see that sequence xn is converges. Let limit xn equals some x. Now to prove this x equals 5 by 3. How? What is x1 given? x1 is 1. What is x2? x2 is 2. And what is x3? From here, x3 is half of x1 plus x2 or x2 plus x1. Agreed? Half of x2 plus x1. So x3 is half of x2 plus x1. What is x4? x4 is half of x3 plus x2. Agreed? Plus etc. xn is half of xn minus 1 plus xn minus 2. xn is half of xn minus 1 plus xn minus 2. Adding vertically, what do you get? X here is x3 plus x4 plus, leave this one. So adding vertically, x3 plus x4 plus etc plus xn. x3 plus x4 plus etc plus xn equals, come to the right side. Half of, take half is commonly taken outside. What do you get? Here it is x2 plus x1. x2 plus x1. Second term. x3 plus x2. Next term. x4 plus x3 plus etc plus xn minus 1 plus xn. Okay. Now listen. That means there is how many x1s are there? There is only one x1. So on right side it remains half x1. Plus, now listen, x2 plus x2, there are two x2. x2 plus x2, half of x2 plus x2, that is x2. So x1 plus x2. Sure. Now, how many x3 terms are there? 2. So half of x3 plus x3, there is x3 and x3 are cancelling each other. Okay. There is x4, again here it is x4, it's also cancelling each other. Again there is xn are cancelling each other. So what remains? So we have here it is half of what remains there, it is xn minus 1, half of xn minus 1 plus xn equals half x1 plus x2. Enough. So taking a limit on both sides. Therefore limit of left side. What is limit of left side? So means limit term of left side equals limit of this one equals limit term half of x1. What is x1? 1. So 1 by 2 plus what is x2? 2. So it is 1 by 2 plus 2 equals 5 by 2. So limit xn plus limit of half of xn minus 1 plus xn is 5 by 2. Agree? But what is this limit? Limit xn, our assumption, let limit xn equals x. Let limit xn equals x. So limit xn equals x, therefore limit xn minus 1 equals x. So x plus x is 2x, half of 2x. So it is what I get? So 3 by 2 of x means 3 by 2 of x equals 5 by 2. That means x equals 5 by 2. Okay, that is the result. Half of xn minus 1 plus xn equals this one. So half x1 plus x2. So it takes the limit. So left side limit is 3 by 2x. So 3 by 2x is 5 by 2. So x equals 5 by 3. That is what we require. Agree? Okay. So it's a lengthy problem, but this is an important problem. Now, we consider a definition. What is a contractive sequence? Consider a sequence x. Let x equals xn be a sequence of real numbers. Then the sequence is said to be contractive. The sequence is said to be contractive sequence. Contractive if there exists a c lies in between 0 and 1, c following open interval 0 1 means 0 less than c less than 1, such that modulus of xn plus 2 minus xn plus 1 less than or equals c into modulus of xn plus 1 minus xn for all n following n. If a sequence satisfies this condition, that sequence is said to be contractive sequence and the constant c is said to be constant of contractive sequence. C is said to be constant of contractive sequence. So this is a contractive sequence. Xn is contractive if there exists C lies in between 0 and 1, 0 less than 0 less than 1, which satisfies this condition. Modulus of xn plus 2 minus xn plus 1 less than or equals C into modulus of xn plus 1 minus xn. So that sequence C is sequence xn is contractive sequence and C is said to be constant of contractive sequence. Enough. Okay. So there is a result. Every contractive sequence is a Cauchy sequence, hence it is converges. That we discuss in next class. Now consider a result. Prove that log n is not a Cauchy sequence. Log n is not a Cauchy sequence. Log n is not a Cauchy sequence. How? What is log m minus log n? We have log m minus log n equals log m by n. Okay. Yes. So what about log 2n minus log n? Equals log 2n by n equals log 2. Log 2 is always positive. Now, choose epsilon equals 1 by 2 into log 2. Log 2 is positive, so choose epsilon is 1 by 2 log 2. Then, there does not exist k following n such that modulus of xn minus xn strictly less than epsilon. Log 2 is positive. Log 2n minus log n is log 2. Put epsilon is half of log 2. So mod xn minus xn, there does not exist such a k with the mod xn minus xn less than epsilon for all n, m greater than or equals k. Therefore, log n is not a Cauchy sequence. So it's a special problem. Consider. What about log sequence log n? So log n is not a Cauchy sequence. By proving this argument, we have log 2n minus log n is log 2, that is positive, but choose epsilon, that is half of log 2. So that does not exist a k which satisfies this condition. Hence log n is not a Cauchy sequence. Okay, thank you.